So we all use the internet, right? Every single day. But have you ever stopped to think about the plumbing? The actual addressing system that lets your phone talk to a server on the other side of the world? Probably not. But there's a huge hidden problem with that system, and it's something we really need to talk about.
I mean, really think about that for a second. What if the internet, this massive thing we all depend on, just ran out of room? It sounds a bit like a sci-fi plot, doesn't it? But this has been a very real threat, one that engineers have been working to solve for a long, long time.
And to really get the solution, you've got to understand the crisis first. This whole story starts with the system that basically built the internet we know and love today, a system called IPv4, and the fact that it was hitting a wall, and fast.
See, back when IPv4 was cooked up in the 1980s, it offered about 4.3 billion unique addresses. Now, at the time, that number seemed astronomical, almost infinite. I mean, there are only a handful of computers connected to the network. They figured it would be more than enough forever. Well, they were wrong.
So what happened? Well, a few things nobody in the 80s saw coming. First, the sheer explosion of people getting online all over the world. Second, the fact that each of us doesn't just have one device anymore, right? You've got your phone, your laptop, maybe a tablet, a smartwatch. They all need an address. And third, the game changer, the Internet of Things, or IoT. Suddenly, billions of new devices, from your smart speaker to your fridge, all need to get online.
Now, for years, we've had these clever little workarounds. The main one is called Network Address Translation, or NAT. It's basically what lets all the gadgets in your house share a single public IP address from your internet provider. But these are just stopgaps. As one source put it, it's like putting a plaster on a flat tire. It's a temporary patch, not a real fix. We needed a whole new tire.
And that new tire has a name, IPv6. Now this isn't just a minor update. This is a complete overhaul, a monumental leap forward designed to make sure we never, ever have to worry about this problem again. Let's take a look at just how big this new ocean of addresses really is.
Yeah, that's a real number. It's 340 undecillion. But honestly, that doesn't even help. It's a number so ridiculously massive that our brains just can't process it. We've literally gone from the 4.3 billion, which is like a small lake, to a cosmic ocean of addresses.
Okay, to help you visualize it, try this analogy. If the entire pool of 4.3 billion IPv4 addresses was the size of a golf ball, then the pool of IPv6 addresses would be the size of the sun. That's the mind-boggling jump in scale we're talking about here.
Still not sinking in? Okay, how about this one? With IPv6, there are enough unique addresses to give one to every single atom on the surface of planet Earth. The takeaway here is simple. We are never, ever running out of IP addresses again. Problem solved.
All right, so we have this practically infinite supply of addresses. But what do they actually look like? They're definitely longer and look a bit more complex than the simple dotted numbers you might be used to with IPv4. So let's break down how to read them.
So, an IPv6 address has 8 different groups of characters, and they're separated by colons. And instead of just numbers, it uses hexadecimal, which means you get numbers 0 through 9, but also letters A through F. Now, I know what you're thinking. Looking at the full example here, it's a bit of a monster, isn't it?
Well, the good news is there are 2 really simple rules to shorten these things and make them way more manageable. Rule 1, you can chop off any zeros at the beginning of a group, so a group like 0db8 just becomes db8. Easy. Rule 2, if you have a whole chunk of groups that are just zeros, one after the other, you can replace that entire section with a double colon, double slash. Just remember, you can only use that double colon trick once in an address, otherwise it would be impossible to know how many zero blocks were removed.
So let's go back to our big, ugly example. First, we'll drop the leading 0 from 0db8 and from 0370. Then, you see those 2 blocks of all zeros right in the middle? We just zap them and replace them with a double colon. And voila, same exact address, but so much shorter and cleaner.
But here's the thing. IPv6 isn't just about having more addresses. I mean, that's the headline feature, for sure. But the engineers who designed it took the opportunity to bake in some really fundamental upgrades that make the whole internet run better, faster, and safer. For starters, security is built in from the ground up. A powerful encryption protocol called IPsec is a mandatory part of IPv6, not an optional extra. The header, which is like the address label on a data packet, is way simpler, so routers can process information more efficiently. Your devices can also assign themselves a unique IP address automatically without needing a central server.
And maybe best of all, since every device can have its own public address, we don't need NAT anymore. This allows for true, direct connections between devices, which is a huge deal for things like online gaming and peer-to-peer applications.
So, at this point, you're probably asking the logical question. If this thing is so great, why aren't we all using it already? And the answer is, well, you can't just flip a switch on the entire global internet overnight. It's a massive, slow, and careful migration, where the old and new systems have to work together for a very long time.
There are basically three main strategies to make this happen. The most common one is called dual stack, which is pretty much what it sounds like. Your devices and networks just run both IPv4 and IPv6 at the same time. Then there's a clever trick called tunneling, where a new IPv6 packet gets wrapped up inside an old IPv4 packet so it can travel across older parts of the internet. And finally, there's translation, which uses special gateways that act like interpreters, letting IPv6 and IPv4 systems talk to each other.
Now, this whole transition has been happening quietly, in the background, for years. Major providers and tech companies have been steadily rolling it out. Which brings us to the most important question of all, because this isn't just some abstract tech trivia. It actually affects you. Is your connection ready for the future of the internet?
And here's the cool part. You can find out right now. If you're on Windows, just open up the command prompt and type ipconfig. On a Mac or Linux machine, pop open the terminal and type ifconfig or IPA. You're looking for an address that's labeled as INET6 or IPv6. But honestly, the absolute easiest way for anyone is to just open a web browser and go to test-ipv6.com. It'll give you an instant report on whether your connection is set up for the new internet. Go on, give it a shot. See where you stand in this great digital migration.